Hi there. So today I wanted to talk about the MVC design pattern and what that means in a real world example. And I want to walk you through the problem I'm facing right now. So as you know, I've been working on this slider, and when I was first prototyping it, I had only a single slider in the world. And when the user clicks the mouse, a raycast is done to check for the intersection here, and that raycast was done inside of the slider. Now, the obvious problem then becomes, well, if I have two more sliders, that means I do 3 raycasts for every single click. But wait, the problem gets worse. These buttons on the side are actually doing raycasts on mouse down as well. So there's like 21 raycasts for this small, simple scene. And that's okay. I don't apologize for that. When I'm building something, prototyping something, I don't want to be, it's hard enough just to figure out what you're trying to build, let alone think about how to build it in a quote unquote proper way. Okay. And wrestling with design decisions up front can actually hinder your progress. So we want to bang stuff out, and we want to see if the whole endeavor will work. Okay, first we're trying to establish, is this experiment going to work? Okay, and I want to use the quickest, dirtiest code possible to figure that, to answer that question. And even if the answer looks pretty positive, in this example, I had the first mode and the second mode, and even then, it wasn't until like the third mode and beyond that I was like, okay, I'm getting really comfortable with the quality of this control, with its usage. I think it has value. So now, in order for me to use more of them in my scene, well, now I have to make things more efficient, more optimized. I need a cleaner architecture that will allow me to more easily build other controls as well. So that's where MVC comes into the picture. So MVC, what we have here is the model. It says model. Over here we have the view, and up top we have the controller. Now, I've used several different MVC patterns over the years on different platforms. They all tend to have their own different flavors, and again, it's only a guideline. So sometimes you break the flow of MVC by maybe putting something where it doesn't belong. So what we have here are 3 camps. Okay, 1, 2, and 3. And over in this camp, the model, this is where we put our data, and we have logic as well, maybe some business logic if we were building some type of web app. And data and functions go quite nice together. The view is basically the user interface widgets, a hierarchy of controls. At the highest level, we have maybe a single view that represents the entire state of the application. And then at the lowest level, we might have, a single button here. And everything in between. Okay, so you can have a whole bunch of views as a composite. And up top here, we have the controller. And the controller, a lot of examples basically make reference of user input as an example. That's a common one. So you could have, in this example, something I'm actually building, is I have a mouse ray. I call it a delegate. I should probably call it a controller. Mouse ray delegate or controller. The term delegate I often refer to as, you want to delegate some work to some actor, and then they'll come back with a response for you later. But controller would also be, well, controller kind of extends into, actually, I'm going to do some management between various pieces as well. So the controller kind of coordinates these two different worlds together. Now, views here should be as flat and dumb as possible. Okay, views should not hold any real data, and when I say data in the model here, I'm really talking about like the app in general, application level state. Of course, views can have their own little pieces of data, and in fact, they need it. So in our slider example here, the current value is different for all of these sliders. So that would live in the model view. And sometimes people refer to this as MVVM. Now, the point I'm trying to stress here is that you should never really take some application data and stuff it straight into the view. Because what typically happens is, that data might get manipulated, it might get copied to other views, and they might change it in a weird way, and you've basically lost control of the true state of the data. So on this side, I like to use the term source of truth. Okay, this represents the source of truth for this piece of data. And I like that term because it really reinforces that concept, like one source. And then a view really just represents the current state of that data at any given point in time. And when you're actually doing, there's actually two ways here. There's retained mode user interfaces and immediate mode user interfaces. I should talk more about that in a future video. I really like the immediate mode type recently, but basically based on this concept of, hey, I have this piece of data, what is the actual view based on that state? And then you discard it every frame and like grab the new state every frame. Now the view, that's not to say the view doesn't have, like we already said, it can have a little bit of data and it can have logic as well. But that logic is really just tied to the presentation of this data. It doesn't operate on the data itself. Now the controller in this example, so I would have this mouse ray delegate or controller, and what it would do is it would kind of sit in the scene. It would drag and drop it out here. It would be invisible, and these individual slider actors can then get all actors of class. Use that. They can find a reference to the mouse ray. And what they can do is they can say, okay, I would like to register myself for any hit events. So the mouse ray delegate handles the left mouse button click, projects a single ray into the scene. If it determines a hit, it looks at all of the views that have registered with it. It finds the one in question and then sends the message directly. So the view will then, like if this is a button in this example, I clicked a button. The button color would change, any logic there. Maybe there's some animation, whatever. And then the view, because this is, in this particular example, is a button, would also dispatch an event out. But the event is not going back to this ray delegate. The event is just going out into this application space. And actually, I wanted to come over here because that is so messy. But over here, and still in this controller area, maybe we have a linear distribution. And it has a controller associated with it. Okay? So when you're dealing with this MVC pattern, you don't try and fit everything inside a single controller, a single model, a single view. Okay? We have our linear distribution with our cubes that we can, position and scale along the axis here. That would be our view in this case. The controller would coordinate a lot of the parameters and how we might change the scale of this distribution here. So this controller would actually be listening for this event that is dispatched from the button because maybe it needs to respond to it and then manipulate this view directly. Okay? So I think that's all I want to talk about for now. I'm sure that was clear as mud. Something else I need to work on just quickly is, as I add my inertia controls, I have to rotate them and size them bigger. But the inertia controls themselves, internally, they have this inertia ball. And the inertia ball is really just a physics constraint on a sphere along an axis. So it can only turn in this direction or this direction. Now, the reason I want to hoist it out of the control is because, and the control I mean as in the view, is because this inertia ball actually represents a piece of data. It's driving the value of that control, and it's doing it with inertia, so it's changing the value over time. It doesn't change the fact that it still represents a piece of data at discrete points in time. So I want to move this into its own kind of like model, and typically I'm going to use a controller for that as well. The controller will create many instances of this inertia ball as the number of views that require inertia balls comes online. So you can see how this kind of works between the controller and models, and controller updating views and views dispatching events, which are picked up by controllers. So the flow of messaging, works up and down here. And down here, I wouldn't do this. And although some people do data binding here. We talked about the source of truth, I think we did, being messed up. Now, what some people have done here is data binding. So a controller will, call a function, piece of logic, data will be updated, and then that data will trigger a data binding, and these views will automatically be updated and reflected. The state of them is updated immediately. And I don't really like that. Because really what happens is if the data changes, I actually might need to coordinate many views together, orchestrate them in some manner based on the context. So say we're doing a screen transition from one screen to another, or I want to dissolve something and then fade something else in. Okay, so I really like going back and forth through this controller. Anyway, that's it for now. That was rather long-winded. I hope I didn't confuse anybody, but that's it for now. Talk to you later.